Good evening, class. Thank you very much. We are meeting today on term 4, Natural Sciences, grade 9. This is exam preparation for November. I'm just bringing you the examination scope revision guide. It's just a full paper that you are working on right now, 100 marks. Please note that this is examination scope. It's a checklist. It's a template of the exam that we are going to write. It's a reference of revision that we are going to do or that we should do as we prepare for our final examination end of the year. And I want you to understand that. Please connect so therefore you don't fail, you don't repeat. Let's all do the best. Uh, what we're gonna do or what we're gonna work on is a full paper right now, which I always want you to understand that when you are given an exam, you should always know that there are instructions that are given there. Instructions are always provided. So before you write any exam, please note that you follow the instructions that are given. You read the instructions. So right now, I just have to remind you that each question or each section might have its own instruction. So this paper consists of 2 sections and 12 questions in total. Section A is 20 marks. Section B is 80 marks. What I'm going to just say is that follow and read the instructions as they are given in class. And please note that by not following the instructions, you are just discrediting yourself towards the attitude of the examiner, or towards the attitude of your teacher. So please note that instructions are very important. So follow them. Check, for example, instruction number 4, answers to be 2 decimal places. When we are going to give any calculations in the paper or in the exam, we must ensure that answers are given to 2 decimal places wherever it is applicable, and then skip a line between subsections. Skip a line between subsections. As you can see, 4.1.1 and 4.1.2. You can always, you are always reminded to skip a line. So without wasting any time, let's go straight to the questions that are given here. Question 1.1, a force is defined as dash. I was saying that whenever you follow this channel, you will never repeat, because these papers that we are working on, almost every piece of work has been provided in one way or the other. So a force is defined as a push or a pull. When we define a force, it is it is a push or a pull. In simple definition, that's what we call a force. It's a push or a pull. When we push something, we are saying that is force, or when we pull something behind us, it is also a force that is applied to an object. So it is defined as a push or a pull. That is right. Uh, let's go to the next question. uh, Use the following diagrams to answer questions 1.1 and 1. And 1.1 and 1.1.3. So we are given that diagrams A, B, C that are given in this regard, and then what is happening is like saying these diagrams are illustrating some different forces that are applied or that are being exerted by people who are in the question there. Which diagram illustrates a tension? Which diagram illustrates a tension? So when you can see tension is to illustrate forces that are pulling in opposite direction. So when we have got the forces that are pulling in opposite direction, we can see that obviously we can see that a tension is illustrated by letter C, where a spring is being pulled in both directions. So I'm saying across, which is identifying that tension is actually what is being illustrated there. So our answer is what? It's C. You can see that is a push on A, as you can see again there. So in any case, what we are saying is that you need to be able to define forces before we go to exams, we should be able to define forces. And then which diagram illustrates contact forces? Which diagram illustrates contact forces? Contact forces. I'm saying go to the channel again. I have defined and explained about types of forces. They are defined and illustrated and shown in some videos that we have in our channel there. So we are saying which diagrams illustrate contact forces. So a diagram that illustrates contact forces, we can see that there should be surface that is being in touch or that is being shown there. So which diagrams illustrate contact forces? We can say A, it is at A, there is contact force as you can see here. There is also the force of friction that is opposing motion. So we are saying A can also be right to say that it's a contact force. And then B, we can't say B because if you can see B, we can't see any contact force there. And then C, it also identifies contact force. C is also identifying contact force, which is showing the tension as well there. And then we are saying D is also illustrating the contact force that is being shown there by that object that is shown through the something like what is it, the scale or something there. So we are saying our answer can be, it can be any combination of the letters A and C. It can be A and D. It can be C and D. So we are saying A and C, A and C can be correct. It can be correct to say A and C shows contact force. We also have C and D can also be fine to say that they also show a contact force. So we have got our answer being C or D. They both show some contact forces that are being illustrated in this case. They are showing contact forces that are illustrated in that respect. So they identified the force pair which the soccer player's foot is the ball. Identify the first pair which the soccer player's foot is the ball. As you can see, the man is diving, hitting the ball there. So which force pair the soccer player's foot is the ball there? So what we need to understand is that we need to understand the forces that are being in motion or in action there. Question 1.4. So we should understand that there is a force of the ground to the ball, force of the ground to the ball. We are saying as the soccer player hits the ball, as the soccer player hits the ball, so we cannot say force of the ground, force of the ground force of the ground on the ball. It is gravitational force, which we are saying when this man is hitting the ball, we can't say that. So it must be the force that is coming uh, from the man's foot and also force of the ball on the foot, which can actually be defined by the actual forces. We are saying there must be force of the man's foot on the ball and also the force of the ball on the foot. So this can be identified by what? By force of the ball. Force of the foot on the ball is correct. When you hit the ball, the force of the foot on the ball is right, and force of the ball on the foot, it also is a double thing. So therefore, we are saying our answer must be B, to say that when this man dives to hit the ball, there is force of the foot on the ball and force of the ball on the foot. So then we are saying the correct answer should be B. And then an electrical component which converts chemical energy into electrical energy. Uh, what is that? An electrical component that converts chemical energy into electrical energy. Number 5. What is it that can convert chemical energy and is converted into electrical? So we should always understand this uh, energy conversion is mostly applicable when we talk about a battery. A battery converts chemical energy into electrical energy. and also maybe into light energy. So what is happening is that a battery is also referred or can also be represented by a torch, by a cell. A cell is a battery. It is a battery that can convert chemical energy into electrical energy, which we are saying the chemical energy of the torch cell of the battery, and then the electrical energy that it is using to provide the power that is needed of it. So we are saying it should be D. It should be D, the function of a resistor in a circuit. A resistor in a circuit. What does a resistor do in a circuit? When we put resistors in a circuit, we intend to do what? In resistors generally are put or basically are put in order to control the flow of current. When resistors are put in there, I remember when when I gave you a presentation that or a lecture that was showing electrical components and their functions. This has been also identified and pointed out that a resistor in a circuit, it is put to control the flow of current. A resistor controls the flow of current. It actually tries to regulate or to control the flow of current. That is the function of a resistor. And then a series circuit. I also want you to refer to the channel that when you look on the types of circuits, we have got a series and a parallel circuit, which we say that these have got also characteristics and they've got their own advantages and disadvantages that you can also find on the channel. What is a series circuit? So what we need to understand is that there are properties or characteristics that we can give to define which defines a series circuit. So is a circuit in which the bulbs are connected in parallel. Obviously, parallel is an opposite of series. We are saying it's another connection. It's another circuit connection pathway, and then provides more than one pathway for the current to flow through. When you talk about series, it's one after the other. They are connected in a continuous in a chain in a one pathway. So when you talk about series, it means they are in a same channel or they are on the same pathway. So we cannot have more than one pathway. Hence, we are saying B can also not do provides only one pathway for current to flow through. And then obviously we are saying a series circuit, it provides one pathway through which uh, through which the current can flow through. It provides one pathway, as you can see. We are saying this can come from this, and then it goes that direction, that until it gets to the position or end of the channel of the pathway that it has to connect or light up. So it provides one pathway. Two identical bulbs are connected in a parallel circuit connected in parallel in the circuit shown below. We are saying two bulbs are connected in parallel in the circuit as shown below. As you can see, we are saying that there are two pathways. That is, we can say one, and then we have got two. So now, what happens? What will happen to the ammeter? To the ammeter, what would happen to the ammeter? Reading when S switch is opened, when this switch is opened, what would happen to the ammeter reading when S is opened? When the switch S is opened, what would happen there? So what I'm saying is that we need also to understand this, as I've said that I have given presentation that explains the pathways or the network or the forms of connection that we can have. So now when S is connected, I mean is opened, the reading will not be affected. Not really, because we are saying that when it is affected, when it is opened, therefore what happens is it will affect the reading. Obviously, the reading will increase or become higher. When it is opened, it cannot be able to increase the reading. It cannot be able to increase the reading because we are saying there is a connection that is cut there, and then the reading will decrease, become what happens is that the reading will decrease or become lower. We are saying when S is opened, when S is when the circuit or when the ammeter, or what will happen to the ammeter when the switch S is opened, we are saying the reading actually it becomes lower. The readings becomes lower on terms of ammeter reading there. What we are saying is there are two bulbs that are connected in that regard. So when S is opened, it actually affects the ammeter reading. Hence, it becomes what? It becomes lower. And then, which of the following circuit components measures potential difference? We're saying potential difference is also defined as what? As potential difference is also defined as one other word, or the substitute, or the other word that we can use is what? Is voltage. So voltage is measured in what? In volts. Volts is the unit of voltage. When we measure voltage, we are saying that the unit for voltage is what? Is volts. So that is how these things are related. So the circuit, uh, one of the following circuit components measures potential difference. So what is it? We are saying it is what? It is D that can be used to measure the voltage that is within a connection pathway or a circuit. Identical light bulbs and cells are used in the following circuits. In which circuit will the identical light bulbs and cells are used in the following circuits? In which circuit will the light will the bulb glow the brightest? Which circuit would glow the brightest? Uh, we need to give the correct scientific term for each of the following descriptions. We need to give the scientific terms for each of the following descriptions and write only scientific term, correct word, and write only the correct word next to the question number. So the rate of electrical energy supply, the rate of electrical energy supply. When we look at the rate of electrical energy supply, it defines electrical power. It defines electricity, or it can defines what? Power. The rate of electrical energy supply, we can say it defines what? It defines power. That can be power, which we can also call electricity. The name of the nuclear power station near Cape Town. So we are saying, what is it that power station that is near Cape Town? I'm sure that you remember that it is Kohlberg. uh, is the nuclear power station that is near Cape Town. And then the type of electricity generated by falling water. We talk about forms of electricity. This is called, when we talk about water, it means it is hydro. Hydro means from water, hydro, electricity. I'm sure I remember that thermal from core, and then we have got nuclear, we have got solar from solar energy, and also we can talk about every other types of sources or other types of power systems. So what we are saying, if it is water, it means hydro. It is electricity that is generated from water is called hydroelectricity. And then I'm saying the most commonest one also is what? Is thermal, which is from coal. I just need you to be reminded as you go towards the exams. And then the device used to step down or step up voltage. We are saying when we are increasing or decreasing, regulating the flow of current, it is regulated through through a transformer. Transformer is used. Transformer, it is used to increase or to slow down or to increase the flow of current, the flow of power within a power system, within a national grid. The green or and yellow wire in the 3-pin plug. This is also on the channel. I have got a nice presentation or a lecture that defines or that explains a 3-pin plug. You need to know the color codes. You need to know the functions and also the consequences of otherwise misconnecting those wires and so forth. So what we are saying is which wire is got the yellow and green in a 3-pin plug. This is supposed to be known that it's an earth wire. It is an earth wire. I'm saying color coding is very important when you look at the 3-pin plug. I was saying that you need to be able to know that. Please refer to the channel on 3-pin plug. 3-pin plug is quite commonest component in our in our syllabus. You need to be able to understand that. I choose a word from column B that matches the description in column A. Write only the letter next to the question number. So we are given uh, the layer of the atmosphere where weather occurs. The layer of the atmosphere where weather occurs. What do we call the layer of the atmosphere where weather occurs? Uh, the layer of the atmosphere where weather occurs. So we are saying we should be able to understand the structure of the atmosphere. I want you to understand that the structure of the atmosphere as we go through our exams or as we go through our science learning, it is a prerequisite in terms of understanding the structure of the atmosphere uh, from the lowest level to the highest, and the characteristics and also the zones that separates them. So I'm sure that you remember that when we go at each phase or at each profile, we are saying the name below the name below it gives the transitioning level or zone that must be named there. We are saying we have got to say the tropos. We have got to talk about the different pose with regards to the types of levels of the profile of the atmosphere. So the atmosphere, the layer of the atmosphere where weather occurs, it is supposed to be known that it is we can talk about the troposphere. It is the troposphere, which we can talk about as to say that is where weather occurs. We can also, we are saying it can be the troposphere, which is B, the troposphere. It is the level or the layer of the atmosphere where weather occurs. In the troposphere, that is where we have got our and then uh, the layer of the earth, which consists of magma or molten rock. We said that the internal structure of the earth is actually having molten, where we have molten rock, it is the what? It is the mantle, which we can say that is what is E. It is E. So you should understand that it is E, which where we have got the which is consisting of magma. We remember again that you shall find a time whereby you are supposed to distinguish between magma and lava. Magma is when it is when it is underground. The moment a volcano occurs and then it erupts on the earth's surface, we call that what lava. So that is one thing that you need to understand again. And then molten, which is liquid rock, which comes out of a volcano. When this molten rock comes out of a volcano, it is called. It must be known that I'm saying already that it is called what? It is called lava. Lava is the molten rock or molten liquid rock which comes out of the volcano from underground. We call that lava. Earth's interconnected web of life, including all living organisms and their environments. Uh, when we look at that, we talk about a biosphere. A biosphere identifies the interconnectedness of web of life, including all living organisms and their environment. So that is what, that is H. That is H. And then a sedimentary rock. What one is a form or is a type of sedimentary rock. A sedimentary rock, we can give that it can be which we are saying it's a sandstone. It's a sandstone which is a form of what, of a granite rock. I types of rocks, we have got metamorphic rocks. We have got we have got metamorphic rocks. We have got igneous rocks. We have got also the sedimentary rocks. So each one of them has got its own types of rocks that are also forming there. I remember, I want you to understand that sedimentary rocks are formed because of fossilization. They are formed, these are forms of rocks that are formed because of sedimentation, which are formed because of deposition. Materials are layered and are pressed down. So therefore, with time and period of with long periods of time with no disturbances and so forth, they they actually form a form of a rock which you call sedimentary rock types. And then we are given the diagrams below, illustrate magnetic, gravitational force and electrostatic forces that are given there. So you can see it's a magnet that is taking magnetic force, which is taking some wires here or pins, and then gravitational force, which is causing this one to fall. It is attracting whatever in the atmosphere to the ground. And then we have got the electrostatic force, which is also shown by this uh, uh, person rubbing the hands and then trying to pick up some piece of papers that are given below there. So now we want to answer the questions that are following. Let's see what is the question saying. Uh, what does the question want us to do? The masses, we want to see what is the question wants us to do there. First question is saying, explain why all these forces are classified as field forces or non-contact forces. Why are they called field forces? Why are they called field forces other than non-contact forces? So what we need to understand is that the objects are not in contact with each other and the forces are exerted, or they are actually the forces are exerted, which is saying that they are being applied over a distance. So when we say they are classified as field forces, it is because the objects are not in contact with each other. Remember when we talked about that one, the last first graph that I was talking about, we were talking about contact force in the first instance, where a block was pushed on top of a surface. A wooden block was pushed there. So we talk about frictional force that is also opposing the movement of the push that is applied there. So now we are saying in that case, there is electrostatic, there is magnetic, and then also all the forces that are given there. So we are saying they are not contact forces because the objects are not in contact with each other. Objects are not in contact. They are not in contact with each other. The objects are not in contact with each other, and forces are what are exerted, and the forces are exerted uh, over a distance. They are not in contact with each other, and the forces are applied. We are saying exerted over a distance. As you can see, magnet it is put not to a magnetic force. We are saying these forces, there is a distance that is there. We have got a distance of the ball to the ground. There is a distance there. The electrostatic force, these pieces are being pulled, but with an object that is put on top, not in contact with them. And also, as you can see, the magnetic force, it is magnet being held up on, on top of some metallic pieces there, which are now being attracted to the magnet. So what we are saying is that they are, when you talk about magnetic force, when you talk about gravitational force, and then electrostatic force, we are saying they are classified as non-contact forces. They are all classified as field forces or non-contact forces. Why are they so? Because there is no contact within or amongst the objects, and also the forces are exerted over a distance, as you can see. So that is why we say they are called field forces. And then what should the paper clips be made of to be attracted to the magnet? For them to be for magnet to attract, we are saying for them to be attracted to the magnet, the paper clips should be made of what they must be. Remember, one, we are saying iron is attracted to the magnet. It has got the magnetization. We can talk about also. We can talk about iron. We can talk about iron. It can also be nickel. Nickel can also be used, or it can also help in terms of increasing magnetization. It can also be, we can also talk about uh, a ferromagnetic substance, which we can say ferromagnetic substance can also be used to make, in order for this to be attracted to the magnet. And then the balloon used to demonstrate the balloon that is used to demonstrate the electrostatic force of attraction between the balloon and the pieces of paper is an excess electrons. He has got excess electrons, that is what we are given there. What is the charge on the balloon? Choose between positive or negative or neutral. So now we are saying the balloon, for it to attract those pieces of paper, we are saying it is used to demonstrate electrostatic force. So what should be the force? Uh, it has got excess electrons. So what has to be the force? What has to be the what is the charge on the balloon? The balloon, actually, it is having electrons. Hence, it is actually, we are saying that for it to attract those pieces of paper, it must be what? It must be a negative charge. It must have negative charge. Remember, we are saying these demonstrations, we also even have them in our classes where we use different pieces of material which can be used to demonstrate electrostatic force. It can be a ruler that is also wrapped on the hair and then put on top of pieces of paper. Then it is supposed to demonstrate electrostatic force. So what we are saying is that it also has to be having a negative charge. And then what is the charge on the pieces of paper? The papers, for them to be also attracted there. Therefore, the papers must be, the papers, this should be an opposite for, we are saying for the attraction to take place, it can be positive. They can be positive. They should be positive for them to be attracted. Unlike poles attract each other. Unlike poles attract each other. So therefore it is negative that is being applied on top of positive. So the papers are positively electrocuted. They are positively attracted to the balloon. So the papers must be positive. And also even when they are also neutral, because neutral can also be attracted to positive. So they can be positive, or they can also be what? They can also be neutral. And then the force of attraction can still exist. An investigation is conducted to determine the relationship between the mass of an object and the gravitational force exerted on Earth on it. I'm sure this we have demonstrated also. I remember also the time I was in class in your grades there, we had such demonstrations where we can also want to show some experimental ways of learning in order to show the reality of things. So an investigation is conducted to determine the relationship between mass of an object, the mass of an object, and also uh, the gravitational force exerted by the Earth on it. So gravitational force, which is also pulling that object to the ground or to have that weight. So now what we are saying is, uh, what is the question saying? Name the two factors that affect the magnitude or strength of gravitational force. Gravitational force, it is also affected by mass. Obviously, I'm sure that you remember that when we talk about the amount of matter in an object, the amount of matter that an object has defines the gravitational force is how much or the force through which it can fall to the ground. So we can talk about that as to say that the mass of an object, one mass of an object affect its gravitational force. That is when we look at, for example, we can give to say when we put an iron solid ball, we throw it in the atmosphere, the speed to which it can fall to the ground is quicker than when we throw a piece of feather because it has got less mass, it has got less weight, it has got less mass. So what we are saying is that the mass of an object defines its magnetic, it actually affects its gravitational force, it actually affects the strength or the magnitude of the gravitational force. And then we can also talk about the distance between the two objects. Distance can also be another factor. Distance also is affect the strength of gravitational force. So we are saying the distance uh, between the centers of the two objects. So the heavier an object is, the quick or the stronger the gravitational force. And also the higher an object is, the more the gravitational force also. Explain the difference between mass and weight. Distinguish between mass and weight. What is the difference between mass and weight? So we want to give the difference therefore. So most of the times I always like to encourage my learners to say that in situations where where you are asked to give differences, I like to, you can either just tabulate it, you can say mass, and then we can say weight. And then we are saying give the difference in these two. So what we are saying is that mass, like I said, is the amount of matter an object is made of. Amount of matter, which is material, amount of matter an object, an object uh, is made of. That is mass. How much is it there that is making up an object? We call that mass. And then weight, when we look about weight, it is the gravitational force the Earth exerts on an object is gravitational force. When you talk about weight, is gravitational force, which gravitational force the Earth exerts on an object. The Earth exists on an object. We call that what? That is weight. So we are saying that is the difference between the two. Mass is the amount of matter an object is made of, or the amount of mass within amount of matter within an object, and then gravitational force. Weight is gravitational force that the earth exerts on an object. How much weight an object has, which is pulled because of gravitational force. And then the weight and mass of different objects are measured. The following graphs represents the results of the investigation. We are given a graph that is going to show us to say that mass and weight of different objects which have been measured, and then we have got a graph that shows the investigation, the results of the investigation. So we are saying, given this, this is it, and then we have got our weight, and then we have got our mass in kgs and our weight in newtons. So the first question is saying, what is the weight of the object? Weight of the object when the mass is 0.1 kg. So we have to go to, on the graph, we identify 0.1 kg, and then we identify and we measure it, or we correspond it to the what? To the weight. So 0.1, this is our 0.1 here. So we go to our line graph and identify where they are correspondingly meeting each other. So we are saying we have got 0.1 and the weight is what? Is 1 Newton. It's 0.1 at 1 Newton. So it is what? 1 Newton. And please note that this one is a given, 1 mark for free. It's 1 Newton, which is actually given because we can see that this is given because what like I'm saying, you can see that there is what? The answer is only reading on the graph 1 Newton. 1 Newton. So I'm saying you are only reading on the graph there. You are not going to calculate anything. You are not going to use some formula. You are only going on the graph, and then you identify according to the way the graph is giving you. 1 Newton, 0.1, which goes against 1 Newton, which is also on the weight there. And then what is the mass of the object when the weight is 4.4 Newtons? So we are supposed to go also on the vertical scale here, on the vertical line, 4.4 Newtons. So we have got we need to understand the interval, how much each line is representing. Each line is representing how many newtons. So we have got 4.4 is on the board line here, and then we have got 3.5 here, and then 3.5.6, 3.5.7, 3.5.8 is 0.6, 0.7, 0.8, 0.9, and then so each line is just representing a 0.1 Newton. So now what we are saying is that 4.4 newtons is supposed to be given. That when we are looking at 4.4 newtons, 4.4 newtons is just not gonna supposed to be difficult, because 4.4 is this one. This is our 4.4. This is our 4.4. Our 4.4 newtons that is given here. Our 4.4 newtons that is given here. Our 4.4 that is given on that line. So likewise again, we take it straight and then follow it to the what? We take our 4.4 straight and then go with it until it touches our line here. It is touching our line after the cross there. So it is touching somewhere there. It is touching our point there. So our point of contact is going to be like saying we have got 0.4. So here now, what is happening is that we are supposed to understand that how much units is each line representing. So it's 0.4 here, 0.4. So we have 1, 2, 3, 4. So how much units does each represent? So we can say 0.4 is it's supposed to be representing 0.2. It is representing 0.2 kg. So 0.4 4.2, 4.2, 4.4, and then it's in between at the center there. So that is now we need to read to say what is the reading which we can find at the center of this line. What is this that we can find here on our mass? Our mass is in between there. So we have got 0.4.2, 4.4.4. So it's between before 4.4.6. So there it is at the center. Hence it is 0.4, 0.4.5. 0.4.5, I'm saying it is just a point of contact, a point coordinates of the line that we are given here, which is giving us the right answer that is 0.4.5. 0.4.5, I'm saying you are just getting it by simply following the same formula that I've said in the first place, 0.4.5. 0.4.5, which is the central point between 4.4, 0.4.4 and 0.4 point 5 before we go there. So it's 0.4.5. I guess we are still getting each other well. So what is it? We are saying it is given there, which is 0.4.5 kgs, 0.4.5 kgs. Is what we are supposed to get if you can do your things right there. And then what is the relationship between mass and weight? When we see this is a straight line, as we increase in mass, our weight also increases. When our weight increases, our mass increases. So we are saying there is a direct, a direct increase as mass increases. We also see a increase in weight. So what we can say is that weight is directly proportional to mass. What I'm saying is when you look here, we are saying 0.1 is 0.1, 0.2, 0.2. I'm sure that we can see this. 0.3, we have got 0.3. 0.4, it gives us 0.4. We are saying there is a direct proportionate relationship, or as mass increases, as each one of them increases, when weight increases or when mass increases, there is also an increase in what? In we are saying it also causes when mass increases, they also have an increase in weight. So weight is directly proportional to mass. Weight is directly proportional to mass. Weight is directly proportional to mass, as you can see from this calculation that I've been just illustrating to you now, that when the mass increases, weight, we are saying weight is directly proportional to mass. That is what we are seeing here. 0.1, 0.1, 0.22. So that is what we are seeing in terms of this graph. As one increases, the other one also directly increases. So there is a direct relationship. There is weight is directly proportional to mass, or we can also say that mass increases, also weight as mass increases, weight increases as well. D. Our next question D. Question D is saying mention one variable mention one variable that must be controlled to make this a fair test. In order to make this a fair test in terms of the investigation that we were saying, what can be what must be controlled. We must control what in order to make sure that what should we control in order to make sure that the results are reliable. We are saying this can also be said to increase the reliability. We are also to increase the correctness. We are saying correctness. It can also be correctness of the results. They also mean the same. So what we are saying is that, remember when what we said is that what is it, the factors that can affect in the previous question there? We said mass, and also we talked about distance. We talked about also the distance between 2 points. So what we need to look at here, what need to be controlled, it is the distance from the, we are saying the distance from the what? From the earth. Distance from the earth. Distance of the earth must be controlled. The distance from the earth must be controlled. We said these are two factors that can also affect, according to our previous question. So distance from the earth must be controlled. So therefore, we can also keep this investigation correct. So that is what you need to understand. And then Elena was instructed to sketch the magnetic field lines between the opposite poles of two bar magnets facing each other. As we can see that this is a north pole and this is a south pole, and unlike unlike poles. So what does unlike poles do? Unlike poles, we say that they attract each other. They attract each other. That is one key thing that we should understand before we do anything. So we are saying the learner produced the following incorrect. The learner produced this to say that this shows that this is wrong, because we are saying they are unlike poles. If they are unlike poles, they must attract each other. Therefore, there must be a flow of connection between the two. So the question is saying the learner drew this diagram, and then which is also incorrect. This diagram is what is wrong. So copy the two bar magnet. Copy the two bar magnet. Redraw the field lines to illustrate the correct magnetic field existing. So we are saying the correct magnetic field existing, it wants you just to know, it wants us just to show that we understand forces. We understand forces to say that these forces, when we are given them, we are able to explain and understand them, to say that when we look at them, how do we work them out in terms of saying we have got the north pole, we have got the south pole there. So what we need to understand is that these forces, they attract each other. So we should have a connection which is showing that there is a connection, and then you can also have uh, something like this, which is also showing the connection. And then we can also, or just let me use a finer ruler here, a finer pencil, sorry. Let me use a finer pencil here. I'm gonna use a finer pencil here to illustrate these forces. So what we are saying is we have got the forces attracting each other there. We have got the force. We have the force also we have got our force showing that it's attracting, and then we also have our force showing that that is how these forces must be like. They must be showing that they are coming, showing a connection, which is showing that the forces are attracting each other. That is one thing that we should take note of. So we are saying uh, the magnetic field. Obviously, what you need to know that in almost that these are just straight magnets. These are just straight magnets that we are seeing here, which are just being shown here. So yeah, that's how you should draw your thing. That's how you should draw your correct magnetic field existing between unlike poles. That's how you should be like. So a wooden box is placed on rough, coarse, inclined surface. We have got a wooden box inclined is on a rough, coarse inclined. As you can see, inclined surface, the wooden box remains in one position and does not slide down the inclined surface. It does not slide down. So now, what is happening is saying the box remains in one position and does not slide down the inclined surface. It is more other ways we can say it is what? It is balanced. It can't move. So now, name the force preventing the box from sliding down the inclination. The force here, we see that there is a force that is, this is a rough. We are saying there is a rough what? There is a rough coarse surface. It is meaning to say that it has got a grip. This thing, it has a grip. So now, the force that must be holding this one, it is a force which is opposing it from moving. Now it has to slide, but there's a force going opposite direction to it. So this is named the type of force. It's frictional force. This is frictional force. Frictional force is causing the box not to move, and then it is frictional force. And then in the diagram above, identify the force that is preventing the box from sliding down the surface. Obviously, like I said, that the box is not going down because of the force C. Force C is resisting, is the resistant force here. Resistant force is C. So what I'm saying is that the force is what? Is C. C is the one that is causing the box not to slide. We said it's the frictional force. So we are given an LED is connected to a cell made from one lemon, a zinc nail, and a copper nail, a copper coin. That is what is given in this question there. And then the question is saying, what is the function of an electric cell? An electric cell is actually there to provide what? The electric cell that we are given there. What is the function of the electric cell? So we are saying it is connected to to a cell made of lemon and a zinc nail, copper coin. So what is the function of the electric cell? The electric cell, basically, as you know, it is actually there to provide energy. It's actually a source of energy. Source of energy. That is why the nail is there. It's a source of energy. It's a source of energy. The LED does not light up, suggests a practical solution to solve this problem. It does not light up. So if it does not light up, we need to have what? If the LED does not light up, what can we do in order for the lights to light up here? We have to have a source of we need to have more power. We need to have something that will increase the power here. So what increases the power for the light to light here? It must be, we have to talk about adding more lemon cells in a series connection. In order to create more power here, we can say connecting or add, we can connect or uh, add more cells in series, add more cells, which we are saying the more cells in what? In series. We said these are, as you can see here, the lemon is actually being used as the lemon is being used as to provide the energy. So we are saying this must be the more cells, we are saying the lemon, we are talking about the more lemon cells that must be in, we must add more lemon cells that are connected in series in order to boost the power supply there. When a resistor is in an electric circuit heats up, the resistance of the resistor increases. And then when it heats up, the resistance of the resistor increases. So what does the question want us to do? So let me check properly. When a resistor, when a resistor in an electric circuit heats up, the resistance of the resistor increases. Yes. So now the question is saying, what is our question in this case? Bulb A glows dimmer, which resistor? I think this question, it has been cut off. So as you can see here, it's just an omission of some statements here. So we are talking about factors that can affect the resistance of a resistor. Factors that can affect the resistance of a resistor. So what we are saying is the factors here, factors affecting resistance of a resistor is what is being asked here. So we need to understand that it is one, length of the resistor. I think you remember that I once gave this one, length of the resistor. Length of the resistor, you know that in terms of the length of the resistor, you need to know that the longer a resistor, the higher its resistance. Also the shorter, the lower its resistance. The length of the resistor, the shorter the resistor, the less its resistance. And also the longer, the more its resistance is correct. And then we can also talk about we can also talk about the type of the resistor, the type of the resistor, type of the resistor, type of the resistor. I'm sure I remember that we are saying some metals, they have a lower or higher resistance than others. So you need to know that also, saying some metals, they do have a higher or lower resistance, have a higher or lower resistance than others. That is it. We can also have uh, number three. We say the type of the resistor. We can also have the other number. We can talk about the thickness of the resistor also. Thickness of the resistor, thickness of the resistor, you need to know that the thicker the resistor, the lower the resistance. The thicker the resistor, ne? You need to know that the thicker the resistor, the lower its resistance. Or we can say also that in terms of the thickness, the thinner the resistor, the higher the resistance also, which is also correct. So now I'm saying factors affecting resistance of a resistor are such as those: the length of the resistor, the type of the resistor, and also the thickness of the resistor, which I have just explained now. So the following circuit are set up, and then bulb A glows much dimmer than bulb B. A, we are saying it is dimmer, meaning to say that this one is what? Is brighter, meaning to say that one is brighter. So now, glows dimmer than B. So which resistor is the highest resistance? Which resistor is the highest resistance? So we are saying the material now of the resistor. So now what we are supposed to understand is that the resistor which have got which resistor the nichrome or the aluminum is the highest resistance. So what we are saying is the A is dimmer and B is brighter. So it means that according to our question that we just answered there, so this one is dimmer, so therefore it has got what? It's got a highest resistance. It's actually having a highest resistance. The one which is dimmer has got the highest resistance, which is being the nichrome. The nichrome, it is actually showing by the amount of light that is in the amount of electricity that is entering, that is reaching the bulb there. So we are saying the dimmer the what the bulb, the more the resistance. The dimmer the bulb, the more the resistance. The dimmer the bulb, the more the more the resistance. That is one thing that we need to take note of. And then we go again. What will happen to the brightness of bulb A if the nichrome wire is disconnected? If the nichrome wire is disconnected from the circuit, cut in half, and one of the halves is then reconnected to the circuit. So we are talking about the length of the resistor. We are talking about the length of the resistor to say that if it is disconnected, what would happen there? So, in other words, this is just an explanation of what we just explained there, that here we are saying the point is that the nichrome is disconnected and cut in half. So we are reducing the length of the resistor. So what we need to understand is that the bulb will glow brighter, because we say the longer the resistor, the more the resistance. So the shorter the resistor, the less the resistance. So here now we are saying the bulb will glow brighter. The bulb, the bulb uh, will glow. It will become brighter. The bulb will go brighter. It will actually, the bulb will glow brighter. That is one thing that you should know, because we are saying the length is reduced. Length of resistor. Length of resistor is reduced. So when the length is reduced, obviously, we are saying less resistance is going to be experienced. Now, question number 6, name one example of the use of resistors in everyday life. Resistors, the use of resistors in every one example of the use of resistors in everyday life. We can talk about the one example. One, we can have we can talk about these elements. You can find them in what? In geysers. We found them in toasters. We find them in stove plates. Stove plates. We can talk about in geysers. We can also talk about them as what? As we can also talk about them in in motors. We use resistors in there, and then also we can also use them in what? In LEDs, which we are saying is called what? Light emitting diodes. Light emitting diodes is also found there. Light emitting diodes. That is also one thing that we need to know. Three circuits are connected as shown below. All the bulbs, cells, and ammeters are identical. They are identical, meaning to say they are alike. They are identical, meaning to say that they look alike. So the question is saying we have got this A, B, C, and then how does circuits A, B, and C differ from each other? How do these circuits differ from each other? The difference in terms of all these, we are saying are all identical. The bulbs, the cells, and the emitters are identical. But what is the difference between these? So we can see that the number of bulbs in series increases from it increases from A to B to C. The number of bulbs that are in series. Check, for example, we are saying we have got 1, we have got 2, we have got 3. So the number of bulbs increases. The number of bulbs increases from diagram 1 to diagram last. So number, you need to be very identical number. I mean, you need to be very observant number of bulbs in series. They are in, we are saying increases from diagram 1, diagram A to B and C. The number of bulbs increases. The number of bulbs in series is increasing. Like I said, we have got 1 there, we have got 2 there, we have got 3. Therefore, that is the difference that we can see there. And then the question is saying 6.2, explain why the readings on ammeter A3 on ammeter 3 will be less than the ammeter reading on 1. Why is the ammeter reading on on ammeter 3 will be less than the ammeter reading on 1 on ammeter 1? So now, so we can need to understand that this question, we need to understand that the more bulbs or resistors in series in circuit you see, the higher the overall resistance also that we can see. So we are saying the ammeter reading 3 is lesser than the ammeter reading on on ammeter 1. Why is it, why is that so? It is because resistors in series, which we are seeing in what? We are having more resistors, we have got more resistors, more bulbs in series that we can see in circuit 3, and therefore we have got higher overall resistance, and obviously we have got lower or small ammeter reading that is given there in what? In 3. So our point is that we are saying we have got more resistors, more bulbs that we are given there. There are 3 here. We have got 3 of them, more bulbs in series, in circuit C, which we can see that our circuit C that we are seeing there in circuit C, we have got 3 bulbs that are there, and then we have got also resulting in higher overall resistance, causing higher overall resistance, causing higher overall resistance. And then also we have got smaller ammeter reading, which is given there, resulting in lower ammeter reading that we are seeing there, resulting in lower ammeter reading that we are seeing on what? On A3, ammeter 3. That is why we have got this difference. That is where the difference is coming from. Study the circuit diagram below. The readings on voltmeters. V1, 3, 4. We have got 2 volts, 7 volts, and 12 volts, respectively. So that is what we are given there. We are saying we have got 2 volts. We have got 2 volts, and then we are saying we have got 2 volts. We have got 12 volts, and then so this is R1, R2, R3, and then goes like that, which is also showing our V1, V2, V3 is also going like that. So now the question is saying calculate the voltmeter reading on the voltmeter reading on V2. The voltmeter reading on V2, we are saying voltmeter reading on V2, our V2 is equals to, we are saying it's going to give us which is 12 volts, which we are saying our 12 volts that are given here, 12 volts, and then we are saying 12 volts minus our we are saying our V2. So what we are saying is that our V2, which is this one, so we are saying 7 plus 2 from 12. That is what we should understand to say 12. We must say V2, which is our V2 here, is equals to 12 volts. 12 volts minus V3 plus what? V1. We must add this one and then we subtract it from there. Minus 2 volts plus 7 volts. So then this is equals to, we say that this is equals to 12 volts minus 9 volts. And then we have got our what? Our 3 volts. We have got our 3 volts that we can get on what? On V2. We have got our 3 volts. That is what we can get. 12 minus uh we are saying V3 plus V3 plus what V1 minus V4 minus those two. So what we are saying is we are saying 12 minus 2V plus what plus 7 volts. That when we get the 9 volts here and then we subtract it from 12, we get what? We get 3. And then the question is saying, which resistor is the lowest resistance? I'm sure that we have been explaining this one to say the one which has got the lowest resistance is what it is. We can say that which resistor has the lowest resistance. It is given that we can have our lowest resistance on what? On a resistor on R1, which you can see we are saying that R1, this one. So R1 is got with the lowest resistance, which is close to R1. It has got the lowest resistance. I said that we talk about the number of cells that are also in series connected to it and so forth. That's how we get this. So R1 is the lowest resistance. Both others are having some cells that are connected there, which are coming from the same, we are saying R2 and R3, we can see that they've got more resistance among on them compared to R1. Also check on the channel class for terms of clarities in terms of these concepts. We are given question 7, circuit 1, 2, are connected as shown below. All the bulbs are identical. All the bulbs are identical. And then explain why the voltmeter readings across all the bulbs will be the same. Why the voltmeter readings across all the bulbs will be the same. So what we need to understand is that when you look on question this one, we are saying the bulbs are connected in parallel and are not in what and not potential dividers. That is one thing that we should see there. And the bulbs are connected in parallel. That is one key thing that I'm talking about, to say that plus the batteries with the same potential, what the batteries have got the same potential difference. The bulbs, bulbs, the bulbs, we are saying the bulbs are connected in parallel. They are connected in parallel. They are connected in parallel to the batteries with the same potential difference. The batteries are with the same potential batteries with the same potential difference. That's what is happening. We are saying these batteries, we are saying the batteries are connected, the bulbs are connected in parallel. As you can see, the bulbs are connected in parallel. Ne? We have got 1 and then 2 there. We are saying they are connected in parallel, and then with the same to the batteries with the same potential difference, the same voltage. You understand? So therefore, the voltmeter readings can be the same. Explain why the total current in circuit 1 is less than the total current in circuit 2. What we can see that circuit 1 As you can see, circuit 1, we are saying circuit 1 here. What happens there is that the bulbs, we have got the circuit 1 has less bulbs connected in parallel. As you can see, the bulbs that are connected in parallel in circuit 1, we only have two. We only have two bulbs that are connected in parallel. Here we have got three bulbs that are connected, and on circuit 2 there are three. So we have got circuit 1 is less bulbs connected in parallel. That is one reason. And then the overall resistance is higher than in circuit 2, which we can see there, and the overall current in circuit 1 is therefore less than that in current what in current I mean in circuit 2. So these are the reasons that we need to take note of. Circuit 1 is less bulbs connected in parallel. Circuit 1 is less bulbs. It has less bulbs connected in parallel. I said they are less because we can see that there is two there, and then they are less compared to that one, three. And then overall resistance is higher than what in circuit 2. Overall resistance is higher than circuit 2. Actually, our overall resistance therefore higher than circuit 2, and then the overall current in circuit 1 is therefore less than in current in circuit 2, resulting in higher resulting in higher we are saying overall current resulting in higher overall current higher overall current overall current in circuit 1 than what than circuit than the current in circuit 2 than current in circuit 2. Current in 2 obviously is less than that in circuit what in circuit 1. I'm sure that we can understand. Current 1, I mean circuit 1 has less bulbs connected in parallel, which is 2 versus 3. Overall resistance therefore is higher than circuit overall resistance in that circuit 1 is higher than what than overall resistance is higher than circuit 2, and then resulting in overall current in circuit 1 uh, being higher than what than that one in circuit 2 is actually overall current in circuit 1. We are saying, don't forget that there is an omission here, less than circuit 2. Obviously, I've mentioned to you that when you talk about resistance, when the resistance is higher, the current becomes less. So when resistance is higher, the current becomes less. That's one thing that you need to understand. That is illustrated by the previous demonstration, which we have seen that we said that the bulb is brighter than that one in circuit B, because we were finding out that there is more resistance in what in one. When resistance is high, therefore the what the when resistance is high, it means therefore that the total current flowing also is gonna be reduced there. So determine the readings on ammeter 1 and ammeter 2, number 7.3. We just want to see what's the reading on ammeter 1 and ammeter 2. This is just similar to the question that we just calculated there, to say that when we calculate these questions or these diagrams, is similar to the previous question that we just calculated now, to say that when you calculate them, you should just use the same formula as we have used in the previous question there. That's one thing that we need to understand. Uh, the diagram below shows an old-fashioned fridge and a modern energy-saving fridge that are shown there. We have got an old-fashioned 800 watts fridge and a modern 380 watts energy-saving fridge that are given in this case. So what is the power rating of the old-fashioned fridge? The power rating of the old-fashioned fridge. It is given that the old-fashioned it's 800 watts. It is given there. It's what is 800. It's 800 watts. Convert this 800 watts to kilowatts. 380 watts to kilowatts. When you get, for you to get this, it's what 380 watts divided by 1000, in order for us to to get them in kilowatts, the relationship of units. So it is 380 watts, 380 watts, which is divided by our, we are saying divided by what? By 1000. So when we divide by 1000, we are going to get, this is going to give us, put it through your calculator, see, you can find out that this will give you 0.38, 0.3, 0.38 kilowatts. 0.38, 0.38 kilowatts. And then electricity is bought and sold in units of electrical energy. Electricity is bought and sold in units of electrical energy. Explain what 1 unit of electrical energy is. This is meaning just to say that 1 kilowatt used for 1 hour, or we can say 1 kilowatt per hour. 1 unit, explain what 1 unit electrical energy is. It just means that 1 kilowatt, it just means 1 kilowatt used for 1 hour. For an hour, 1 kilowatt is used for an hour, or is used in an hour. That is what 1 unit of electrical energy. And then we are given this, calculate the cost of the cost to use 800 watts old-fashioned fridge for 10 hours if the unit price of electricity is 3 rand. So we are saying cost, we need to know that cost is equals to power ratings of the appliance. It's equals to power rating of the appliance power rating of the appliance times time used multiplied by time used multiplied by unit price of electricity multiplied by unit price of electricity multiplied by unit price of electricity. That is how we calculate the cost of electricity. So it is power rating of the appliance multiplied by time multiplied by unit price of electricity. So therefore, what we are saying is that the power rating, we need to understand that the power rating is given there, which we are saying that we convert it to what? To kilowatts. So we have got our power rating used to calculate the cost to use the 800 watts. So we are saying the cost is equals to, we are converting this to kilowatts, 0.80 multiplied by we are saying multiplied by time, 10 hours. Our time multiplied by 10 hours, and then multiplied by unit price of electricity. Our unit price is what? Is 3 rand multiplied by 3, which is going to give us that multiplied by this. We put it through a calculator. We can say this can give us 24.0, which is close to 24.0, which is 24 rand. Which is 24 rand. That is the cost of using the old-fashioned fridge. And then calculate the cost to use the modern fridge for 10 hours if the unit price is this one. So we are just doing the same thing again. The cost of using the new machine, the modern one, the cost is cost, we said power rating. It's saying power rating of appliance, power rating of appliance multiplied by time, multiplied by cost, multiplied by unit price of electricity that we are given here. So our power rating is equals to, we are saying calculate this one. We do the same again. We need to convert this one also, our power to what? To our kilowatts. So we are going to have, we're going to have 0.38, which is our power rating, 0.38 multiplied by 10 multiplied by 3, and then we are going to get this is gonna give us to it's gonna give us, when we give this in our money units, we said to 2 decimal places, so it's gonna give us 11 rand 40 cents. 11 rand 40 cents. In the odd one, it gives us the cost being 24 rand. This one is 11 rand 40. That's what we need to understand here. Let's go to the next question. The diagram below shows how electricity is generated. So what is, we have got core arrives by a train or a truck, which is here. The core is arriving by a core or a truck. Water is turned to steam in the boiler, which is being shown here. And then we have got the steam cooled in cooling tower, which is there. So now what is happening is, the question is saying provide a suitable heading for the diagram. This is just when you see this diagram, given this diagram, what can be the suitable heading for it? We can just call that power generation. We can talk about We can talk about a coal-fired power station. Coal-fired power station is what we can see here, that we are seeing coal arriving there and then water turned to steam by the boiler. The steam is cooling system, whatever that is being given there. So it is electricity generation. It is coal-powered station, coal-fired power station. And then what fuel is used to boil the water there? What fuel is used to boil the water? As you can see, the coal just arrived by a train. So what fuel is used? We are using what? Coal is being used in that case. As we can talk about coal-fired, what is used to make the turbine rotate or to turn? The turbines are turning as a result of what? Steam is cooled in cooling water. I'm sure I remember that the turbines are turned because of they are turned because of the steam. We are saying the turbines are turned because of the steam that is running or that is coming from the water, the boiling water. It is the what? It is the steam. Label part 4 in the diagram. Label part 4 in the diagram. Our part 4 in the diagram, which is part 4. Part 4, it is just showing now the electricity being discharged to where the electricity is now being discharged. So what we are saying is part 4 on the diagram, if you can check there, it is actually showing the generator. Part 4 is a generator here. That is a generator. Give a reason why this method of generating electricity is not sustainable. We are talking about the disadvantage of having electricity from what? Generating electricity from coal. So coal basically is just it is non-renewable. Coal is non-renewable and can also cause a lot of pollution. Is not environmentally friendly. Is not environmentally friendly. You are saying it causes too much pollution, too much air pollution, which we can say it results in environmental degradation. We can also talk about saying coal is non-renewable. Therefore can be finished. Can be finished. That is a problem with coal. Coal can be finished. And then suggest 3 alternative methods that can be used to generate electricity, which is sustainable with very little impact to the environment. We have got other alternative sources of energy. We can talk about solar energy is the most one that we have now, where energy is generated from solar. We talk about the hydro energy, which is from water. I'm sure that we understand. We know the hydro energy comes from water. Also, we have got we can also talk about the wind energy. Wind energy is also very correct. It can be used. And then we can also talk about geothermal energy, which can also be used. Geothermal energy, or we can also use waves energy. Those are also other alternative sources of energy that can be used. We have got a diagram showing the soil. Answer the question that follow. Question first is saying name the earth sphere composed of soil, rock, and various minerals. The earth sphere that is composed of rock, and then those are the various minerals. As you can see, I'm thinking that you remember that we have been talking about types of spheres. We've been talking about the various spheres that we have. So I'm sure that if you can relate very well, you are able to understand that we talk about the biosphere, we talk about the lithosphere, we talk about the thermosphere and whatsoever. So now, what we are saying is name the earth sphere composed of soil, rock, and various minerals. It actually identifies the what? The lithosphere. Lithosphere is the one that has got the rocks, you have the soils, you have the minerals in there. The lithosphere is the one that identifies these. And then what role does the earth's solid surface play in supporting the tree? It actually uh gives the roots to anchor there, and also the nutrients, the role the earth's solid surface, it actually provides anchoring of the roots. Uh, it actually provides anchoring, the supporting support function, the tree to stand, it supports the tree to stand, it anchors the tree. It also we can also have the earth's the solid surface, it actually provides the anchoring. It can also we are saying keeping the tree straight, maybe even also the provision of water, which is also from underground. That is also another function that we can give. Water in the ground is really important for tree growth, of which sphere is the underground water a part of. Obviously, you know that it is part of the hydrosphere. It is part of the hydrosphere. It is part of the hydrosphere. And then hydro means water. And then we are saying it is part of the hydrosphere. That is one thing that you need to understand. Explain how the air of the how the air part of the atmosphere around the tree is involved in its life process. It's actually like we are talking about in terms of the air in the atmosphere, and then the supporting around the life of a plant. It is actually enables the survival of the plant of the trees by promoting what the trees can make their own food. Trees can manufacture their own food through photosynthesis. Through photosynthesis by absorbing carbon dioxide in the atmosphere. So for plants to survive, they absorb the carbon dioxide in the atmosphere in order for the trees to make their own food. They absorb the carbon dioxide in the atmosphere so that they can make their own food. So that is what we need to understand. in this case. And then we have got the diagram representing the structure of the earth. It represents the structure of the earth, and then provide labels for the layers marked PRS. What is P? P is the, as we can see, it is actually, P is the inner core. P is the inner core, and then R, as you can see, R, it is the mantle, and then PRS, S is the outer layer, which is actually the crust, is the crust. So is obviously Q, if it is asked, is the outer core. Q is the outer core if it is asked, but of course in this case is not asked. And then consider the picture of a volcano. Consider the picture of the volcano. So class, you need to be able to know the structure, the internal structure of the earth, in order for you to be able to relate and answer every other question that comes there. So what is the molten rock called when found on the side, on the inside, uh, when it is found on the inside of a volcano? We answered this question in the beginning again. We said that when it is still inside, it's called what? It's called magma. When it is inside, it's called magma. And then what type of rock is formed when the molten rock from a volcano cools down and solidifies the crystallization on Earth's surface? It actually forms igneous rocks. Igneous rocks are formed. It is an igneous rock that is formed there. And then explain why fossils are not found in igneous rocks. Fossils actually are not found in igneous rocks uh, mostly because we are saying that you need to know that these fossils are not found in the igneous rocks. Uh, are not found in the igneous rocks. It is because plants and animals remain trapped in the what? In the lava. They remain trapped in the lava, or igneous rock will be burnt due to the what? To the extreme heat. The remains the remains of living organisms which may remain trapped, which may remain trapped, which may remain trapped in the lava or igneous rocks, which will may remain trapped in igneous rocks. What happens is that they will be burnt due to extreme heat that is involved in the volcanoes. They will be burnt due to extreme heat. That what happens there. Remember that the igneous rocks are formed from volcanoes. So in the process that there is any remains that might be found, the animal remains that can be found in the rocks, they may be burnt off due to extreme heat that is involved in the volcanic eruption. And then explain how metamorphic rocks are formed. Uh, Metamorphic rocks, they are formed when rocks are subject to high pressure and high temperatures. These are formed from either igneous or sedimentary rocks. Sedimentary rocks which are exposed to high temperatures and pressure. So what happens is that when igneous rocks and sedimentary rocks are exposed to high temperatures and pressure, they change to metamorphic rocks. They change to metamorphic rocks because of what? They change into metamorphic rocks when they are exposed to high temperature and pressure. They change to metamorphic rocks. Which of the following, which one of the rocks types mentioned below is an example of a sedimentary rock? Sedimentary rock, obviously, we are saying from burial of material, it is what? It is core. Core is an example of sedimentary rock. It is core, which is actually is an example of sedimentary rock. And then the graph indicates average temperatures of the Earth's atmosphere at different heights above the surface of the Earth, which represents the atmospheric layers. The atmospheric layers are represented. So we are given that provide the names of the atmospheric layers A, B, C, D shown in the graph. Write the letters A to D followed by the name of the what? Of the correct atmospheric layer. So for me, I'm just going to write the names on the graph so that we cannot just be able to do more on that. So what happens is that we need to know that when we look at A, it is the troposphere. A is the troposphere. A is troposphere. And then if we look at B, obviously the next layer which forms is the stratosphere. Stratosphere. And then A, B, C, D, C, it is the mesosphere. And then D, obviously, D, it forms the thermosphere. That's our sphere. These are our atmospheric levels that we need to know: troposphere, stratosphere, mesosphere, just like that. And then write down the temperature of atmospheric layer B at height 20 above the surface of the Earth. So if you look here, we should look at layer B at height 20, layer B at height 20. When you look at height B, we just have to come to the graph and then we read it like that. It is what? Minus 60 degrees Celsius. Minus 60 degrees Celsius. And then the next question is saying, write down the relationship between the height above the Earth's surface and the temperature in layer B when moving upwards from 20 to 50 kilometers above above the Earth's surface. So the relationship in layer B as we move from 20 to 50 kilometers, 20 to 50 kilometers layer B. So we are saying as we move from here to 50. So we are saying this distance, what happens? We can see that it is actually illustrating that we have got there as we have the temperature increases with increase in height here. Temperature increases with increase in height. So from 20 to 50, we are seeing an increase in temperature increases with an increase in height. So as we can see here, we come here, it goes to 40. We come there, 40. It goes there. As we go again up to 50. So we are saying temperature is increasing with increase in height. Temperature increases with increase in height. We have got our temperature increases with an increase in height. Temperature increases with an increase in height. And then next is saying 4, write down the name of the thin layer of gas found in B, responsible for protecting living organisms on the surface of the earth against harmful radiation. So when the sun is coming, in order for it not to be too intense, we are saying in layer B, the layer that protects living organisms from extra incoming solar radiation. What is that called? It is actually called the ozone layer. Ozone layer is the ozone, write down the name of is the ozone layer. It actually protects the earth from overheating. The earth is protected from overheating by the ozone layer. That's one thing that you should understand. The ozone layer protects the earth from overheating. And then give two negative consequences of the phenomenon known as global warming. Global warming, we are talking about extensive increase in global temperatures. That increase in global temperatures is what we call global warming. Temperatures, they keep just increasing, which is causing a lot of negative effects. So we can talk about issues to do with food shortages of food, because when temperatures increases, we can have low harvest and less rainfall giving into that. We can talk about climate change. Climate change, what it does, it can also cause, which can also result in what? Severe droughts. It can result in what? Desertification. Desertification can also be experienced. We can also talk about health risk problems. We have got diseases that are caused because of heat waves. We can talk about cancerous diseases. Cancerous diseases are caused by extreme temperatures. We can also talk about problems to do with other problems that we can talk about is poverty. People just will lack extensive lacking that is caused because of extreme bad weather conditions. We can talk about high death rate of people. High death rate of people which are caused because of weather conditions that are very uncomfortable. These uncomfortable weather conditions that are coming in there. You can also talk about rising sea levels, coastal flooding, temperatures, melting of glaciers, rising of sea level, causing coastal flooding. And then we can also have mass extinctions, mass extinction in various species of organisms, mass extinction of organisms, mass extinction of organisms. Organisms, they die and they get finished because of this. So negative effects that are caused by global warming, there are quite a lot. There are quite a lot of them. So class, I want to appreciate your time for connecting and following. You have a wonderful stay and all the best in the upcoming exams. I guess we have done a quite an extensive revision. Just try to keep on following. You can go through it in a number of days. One day you watch this segment, the other next day another segment until it is done. You will see that there are quite a lot of questions that you can learn from. And I've said that question 7, because it's a continuous repetition of questions, we just tend to leave some of the questions because they are more or less the same, which are just using similar formulas that we have calculated with. So thank you very much for your time. All the best. Let's meet again in the next upcoming videos. Just keep connected and don't forget to subscribe, like, and share our channel. Thank you very much.